Hi, I'm Patrick Hopkins, Professor of Mechanical Engineering and Director of the ExSite Lab. We study heat transfer materials, from those you'll find in a computer chip to those you'll find on a jet airplane. We use lasers to measure properties of materials like thermal conductivity, heat capacity, and temperature. Let me show you around. This is time-domain thermal reflectance, a pump probe technique we use to measure thermal conductivity.
Hi everyone, my name is Kumar Saryana. I'm a third-year PhD student at Patrick Hopkins Group. Here, using lasers, we measure thermal properties of material at nanoscale.
Come on in. My name is John Gaskins. I'm a principal scientist in the ExSite Lab. This is our evaporator. We use our evaporator to put down thin metal films, and those metal films help turn the optical energy from our lasers into thermal energy. And that thermal energy is how we are able to measure the thermal properties of materials. I'll show you exactly what we got going on here. So we put down 80 nanometers of aluminum and they come out nice and shiny like that.
Hi, I'm Dr. John Tomko. I'm a research scientist at Patrick Hopkins Lab, and here's where we develop tunable wavelength spectroscopy systems to push the next generation of TDTR.
Hi, I'm Kate Tomko, and we are looking at the melting and damage mechanisms of materials using lasers. Hi, my name is Emma Tiernan, and I'm a second-year PhD student here in the ExSite Lab. And today I'm working on one of our laser systems called PLSP. It's the same as the first laser system you saw before of HQ. But this one is at 800 nanometers for the pump.
Hi, my name is Hans Olson. I'm a fifth-year PhD student at the ExSite Lab, and I've been working on developing new metrologies to measure the thermal conductivity of thin film and bulk materials. Specifically, what I've been doing is taking our free space optical table that we have over there and integrating it into a fiber optic setup, which is more easy to use and more high throughput in engineering. Follow me.
I am Eric Hoagland. I'm in Patrick's group. I'm one of the new postdocs. And this is our microscope. We now have to operate from the second room because stability is a big thing. So what we can do here is we can actually look at the atomic structure of materials. So here you can see we have a superlattice, which we've done lots of thermal measurements on. But we can actually tell what the atomic structure is, how these materials are put together, and correlate that with the thermal measurements.
Thanks for taking the time to learn more about our research, our facilities, and our work. I look forward to hearing from you.